Okay, at the end of the last video, I asked you to try to draw for me the way you would represent the three coordinate planes that we have right here. So I just want to go through that real quickly. So I've drawn in the axes here. If I want to draw in the XY plane, I'm basically just going to draw in a rectangle in the XY plane. But my rectangle isn't going to look like a rectangle because its sides are going to be parallel to the x-axis and the y-axis. Okay. So I can say, let's come up a certain height. There are two lines that are parallel to the y-axis. Now let's connect it with two lines that are parallel to the x-axis. And then let's just erase to clean it up a little bit. I sometimes find it helpful to draw in a line that's a little bit too long and then clean things up. What I did try to do, and I can clean things up a little bit more. What I did try to do is make it so that the center is here. This is the one point where it's obvious that the z value at that particular point is equal to 0. So you want to try to make the center of the rectangle that you're drawing be a point where the coordinate is clear. If it's 0, you can just have it centered as it is like so. If you remember when I graphed x equals true, I had dotted lines going through the center of the rectangle that I drew so that we could see that the x value at that center point was 2. The YZ plane is probably the easiest because the sides are going to be parallel to the y and the z axis. So if you've gone the way I have here so that your y-axis and your z-axis are actually perpendicular, you're just drawing a rectangle that actually looks like a rectangle. Okay. Now, there will be times when we're dealing with finite shapes so that we mean to actually literally have boundaries. There are going to be times when we're dealing with infinite shapes so that the boundaries are just meant to indicate, oh yeah, we go out this way and we go out this way. Okay. And that's just always going to have to be clear from the context. Okay. Here I've labeled, this is the YZ plane. I know that's infinite. So I know that that's not the whole thing, that's just a representation of that infinite plane. For the XZ plane, I'm going to be drawing a rectangle. Again, it's not going to look like a rectangle though, because my right angles are going to be created by lines that are parallel to the x-axis and parallel to the z-axis. So if I draw in a couple of lines parallel to the z-axis, and then a couple of lines parallel to the x-axis, and then just erase the extra. That gives me my XZ plane right there. Again, I tried to make it so that the origin was at the center of the parallelogram, which is really a rectangle, it just doesn't look like one, that I drew so that we can see, oh yes, the y value at the center is equal to 0. Okay, a couple of other things as we're working with 3 space. If we're in 2 space, the x and the y axis divide up the plane into 4 parts, and we call those the 4 quadrants. Okay. Now, if we're in 3 space, the x, the y, and the z axis actually divide the plane up into 8 regions. Okay. So here's the xy plane right here. This is the positive x and this is the positive y axis. So this would be quadrant 1 in the xy plane. There's the octant above it. That would be where x, y, and z are all positive, and we call that octant 1. So this is the positive x, positive y, positive z. Octant 1 is the region where x is positive, y is positive, and z is positive. Now, there are obviously 7 other octants. Here, we would have y is positive, but x is negative. That would correspond to quadrant 2. I've got an octant above it, and I've got an octant below it. Back here, y is negative and x is negative. This would correspond to quadrant 3. I've got an octant above it and below it. And over here, x is positive, but y is negative. That would correspond to quadrant 4. I've got an octant above and below it. We don't actually number all 8 of those octants. The only one that has a number is octant 1. All of the others, they're octants, okay? But I basically describe them as I'm in the octant that's above quadrant 2, or I'm in the octant that's below quadrant 4. So they don't have a special numbering system with the exception of octant 1. But in octant 1, all of my coordinates are positive, and that can be an important thing. Okay.